Hi all, my name is Mads Barnkop from Kaizer Electronics. Welcome to part 4 of the Tesla Coil show controller build. Today we are taking this 3-unit plate, and in this we're going to mount the Synthoraptor display itself, which we have here. I want to mount the display with the microcontroller behind it, but that's not all. As I showed on my overview drawing, I would also like to have 6 individual normal controllers or interrupters and a master controller. So taking these 3 bags of potentiometers and some more switches, I would like to have 7 interrupters sitting here and then the Synthoraptor over here on the right side. So let's see how that will turn out. This is the 3-unit panel that we're going to mount all this stuff in. It is the display itself that will sit out here on the edge, some USB ports just above it, and then all these potentiometers and switches sitting all over here. So I made some kind of plan that I'll try to use for this. I draw this up in draw.io, the online drawing program that you can also download. It's pretty nice because it's just so simple, but the print function is absolutely, I wish it was more elaborate. Let's just put it like that. So you can see that's very tight. That's all some 34 millimeters between the potentiometers and 16 to 18 millimeter between the switches, and the display and ports over here just well fits in there. So I will just get the whole panel covered in masking tape, because the hole for the display will be cut with my angle grinder. So that can be quite messy on already pre-painted panels. But I have done that a lot before, but that have also been displays with a much larger bevel to cover the damaged paint. When you use an angle grinder, do get a little bit hot for the paint. With all holes done, it is time to mount all the hardware. A lot of potentiometers, a lot of switches, a lot of mounting to do. So again, some masking tape on my tools not to scratch the painted surface. I need to make some kind of plate sitting underneath the display to hold the microcontroller, and I also need some kind of metal framework behind the plate to hold the 7 interrupters. With all the potentiometers and switches in place, I have cut up all the wires that I need for it. And that turns out to be 91 wires. And I have a sudden flashback to when I said something about building a large Tesla coil and maybe something a large suitcase. That do take up a lot of space. So yeah, here we have the 6 colors that was used for the signal on the output board. I have the same colors used for the signal coming from each interrupter here and from the Synthoraptor. So in order to keep the same color coding on those signal wires. Then for the switchover switches between normal and burst mode, I'll use these because that's the same colors I used for the switches on the other panel. And then for all the potentiometers, I will use the same 8 colors for each row. So when looking at this from behind, everything should be exactly identical between each of the 7 interrupters. Should make it somewhat easier to spot a fault. So I think I'll have to do a lot of removing insulation and soldering. It has been a good 7 days since I put all these wires in place, and because I have been waiting for some PCBs to arrive and also some Ethernet connectors, because I would like to add a Ethernet connector to the microcontroller that we have here, as it has one, and Max was thinking about adding a feature to connect to this via Ethernet instead of USB, which would be more stable. I also put the microcontroller on a nice piece of IKEA breadboard. Nice material for building stuff cheaply. Now the display here luckily has a dent in the indent here in the PCB, so I could actually place the Ethernet connector, which turned out to be quite larger than I expected, so that can just narrowly get put in place here while the display is mounted in the holes that I already made for it. Now, getting this a little narrower did cost me one, so it was a good thing I ordered 2 of them, because it is just a regular Ethernet socket that has been put into some melted plastic housing here, and actually the wires were running quite high up into this plastic encasing, so even at first try I did actually saw through 3 of the wires, so that was quite fast that I destroyed that one. Now what I also got, and what brings me to a lot of work to come, is the PCBs. So here I have 10 of the interrupter PCBs from Prof 9 DC's PCB pack, which can be found for free on highvoltageforum.net. I will leave a link in the description for it. So I'm only going to use 1, 2, 3, 4, 5, 6, 7 of these for this project. So that's a lot of soldering I have to do. And I'm thinking I could as well just populate the last 3 while I'm at it. So why not just build all 10 at a time? So one of the PCBs do actually have a long scratch all over the surface here, and it actually seems to be quite deep, so I'm just gonna throw that away. Maybe test that later, so I'm going to build 9. I think I mentioned that this project does evolve a bit along building it, because this interrupter can actually also take a sound input, and not a, it could be a MIDI input, but as a normal sound wave output. So this could actually be connected to some kind of instrument or all kinds of analog music source. So I will add that option, so I will have to build another panel with another switch, with a plugin for the sound input. But since this interrupter has the option, it would be a shame not to implement it. So a bit more wire work. Time really flies when you enjoy yourself with a little soldering. So I think I'm some 5-6 hours into this project here, or just populating these boards, of course. Now I left out quite a lot of components that has to do with the MIDI controller, because I have another one I will use instead, and also the optic output and all the potentiometers and switches, which will be connected up to another panel. All wires are now nicely soldered up, and come to think of it, I probably should have looked into getting potentiometers that would just get soldered directly into here and mount to the front of this panel, but yeah, lesson learned for another time. So I dug into my bins of standoffs from different teardowns, and I think I have a plan of having a small and a large post. So just supporting the board in the diagonal corners, something like that. And then with some other standoffs put in between each layer. So that should space out nicely and seems to correspond with the distance I have between the channel rows here. So let's get all that mounted. That turned out pretty damn solid. I'm very happy about the solution. This is very rigid. That is going absolutely nowhere. Have some power terminals sitting here with a slanted terminal so I can mount the power to the 7 interrupter cards here. And then there's of course just left figuring out all the regular sound input and controls sitting at the end here. That will go up to another panel sitting on top of the output panel that is over here. And then we have the output plug here, which goes from the interrupters to the uptick output panel. Finally, it has come to give you a demonstration of the 6 interrupters and with the 7th master interrupter, and also connected up to the output panel. Now the output panel, you might remember, has these optical outputs, status LEDs. We can turn the output on and off. We can connect a speaker for dry testing, which it has now, and we can select between 2 different kind of interrupters. Right now we have selected the analog interrupters. The selector switch down here selects the missing synthorupter. So that will be in another part. So right now I have only the master engaged. I am completely missing any kind of markings here, so I will get that done pretty soon. But the master is the only one running now. We have BPS, pulse width, and then the 2 burst mode on off times and a burst mode switch. So let's just turn up the on time. And we can also hear the speakers being louder now. So let's turn up the BPS. Alright, let's try burst mode. Okay, so I can also choose not to run all the channels on a master. They can run on single. So if we try to turn on all the single channels, and they are just running in normal mode now, and we have the master channel on burst mode, but that is no longer in effect. It's all disabled. So now it's all controlled by each single channel sitting here. So yeah, we can adjust all manually. And we can also go into burst mode. And we get this nice weird galloping effect. As nothing is really running in sync here, everything is running 6 channels asynchronously. Gives a very nice effect in my opinion. All stickers and knobs are now on and it looks absolutely fabulous. I'm thrilled how this actually turned out. So if I just would like to give you one last tip, and of course I spared you for the time lapse of putting on knobs and stickers, but when you put on stickers on a panel surface like this, it's of course always a good idea to clean it of grease with rubbing alcohol, but use a small pointy flat-headed screwdriver. Simply get in under the sticker, just slightly grab it, and now you have absolutely full control over placing the sticker at any angle you like and position it precisely. And this is a very good way to put on stickers and maintain full control and to align them up against each other. So that's a nice trick. You can also use something like a very sharp knife that is also has a very sharp edge, also good for grabbing in under stickers and placing them. So let's just play a bit with the interrupter. Right now we're running in burst mode on all channels set to master, and let's just ramp that up. This is finally the end of part 4, and it took way longer to complete than I first imagined. A part-time education, final papers, waiting for parts, and as you could see on all the time lapse, this took a really long time to put together. And I had a few design choices to also develop doing assembly, so there was a few mishaps and I had to rebuild a few bits here and there. Also, the now added functionality of the audio inputs, I will have to find a panel and also find parts for that. So that will probably be in part 6 or 7. But for the next part, part 5, we will look into mounting the Synthoraptor 7-inch touch display with microcontroller and also test the whole setup with updating firmware, get it to run with the outputs, and just overall get these two panels mounted back into the 19-inch rack. So thank you for watching, and until next time, see ya.